Welcome to this session. We are going to describe the method of undetermined coefficients applicable in finding the solution of non-homogeneous linear second order or third order higher differential equations. So given a non-homogeneous equation of the form ay double prime plus by prime plus cy equals to g of x. So this is the main equation. So we are going to call it star, where A, B, C are constants. With a given set of initial conditions. So then we are interested in finding the solution of the star equation. So the steps are: 1, find the general solution of the corresponding homogeneous equation. So the homogeneous equation is simply fixing the right-hand side to be 0 and then solving the left-hand side equation. So call this solution yc of x, or you can call it yh of x, where this means complementary or homogeneous solution. So that is step 1. Number 2, make sure that the function g of x in the equation star belongs to the class of functions of sines, cosines, exponential functions, polynomials, or sums or product of these functions. So g of x will be in any of these class of functions. If not, use the method of variation of parameters. So when the g of x is not in any of this group of functions, then the most suitable method to solve that non-homogeneous equation will be the method of variation of parameters. Now let's assume that now the g of x is among any of this, is one of these possibilities of functions. Then that leads us to step 3. If g of x can be given as g1 of x plus g2 of x plus gn of x, i.e., if g of x is a sum of n terms, then form n subproblems each of which contains only one of the terms g1 of x, g2 of x, up to gn of x. So the I subproblem consists of the equation A y double prime B y prime plus cy equals to gi of x, where I runs from one to n. That's step 3. Once we are done with step 3, step 4, for the ith subproblem, assume a particular solution yi of x consisting of the appropriate exponential function or sine function or cosine function or polynomial or constant function or combination thereof. So if there is any duplication in the assumed form, of this yi of x with the solution of homogeneous, this is very key, homogeneous solution of the homogeneous equation found in step 1, then multiply yi of x by x, or if necessary, by t squared, so as to remove the duplication. So see the table below. Now, if we have gi of x, if we have this is a polynomial, then if there's any duplication, say x times x power s into a n x power n plus a n minus 1 x power n minus 1 plus a1 x plus a naught. So this is the guess function, guess or trial function. If gi is of the form e raised power alpha t, then we have x power s into an x power n plus an minus 1 x power n minus 1 plus a1 x plus a naught. Then you multiply by e raised power alpha t. If this is the case, Pn of x by that. And then if we have Pn of x e raised power alpha x, and then multiplied by either cosine or sine, or polynomial times e raised power alpha x cosine of beta x, will have x power s an x power n plus an minus 1 x power n minus 1 plus a1 x plus a naught e raised power alpha x cos beta x plus bn x power n bn minus 1 x power n minus 1 plus b1 x plus b naught e raised to alpha x sine beta x, where s is the smallest non-negative integers so s can be 0, 1, or 2. That will ensure no terms in yi of x is a solution corresponding to homogeneous equation. And then number 5, find the particular solution. Find a particular solution, yi of x, for each of the sub-problems then the sum y1 of x plus y2 of x up to plus yn of x is a particular solution of the full non-homogeneous equation star, and call it yp of x. So 6, the general solution of star is now yc of x plus yp of x, or we can say yh of x plus yp of x, where yc or yh is the solution of the homogeneous equation. And number 7, lastly, use the initial conditions to determine the values of the arbitrary constants remaining in the general solution. So remember, the general solution is y of x given by this. So in summary, we can give a table of some values of the nature of g of x and what should be picked as a trial particular solution. So summary of trial solutions for YP. So the nature of G of X will be in the left column, and then this will be the trial particular solution, YP of X. So P is a constant. So if we have a constant as your G, then you also assume a trial solution to be also just another constant. Now, if your G of X is a linear function, then also your guess for YP will also be a linear function. But remember, you have to put this A1 and A0 and solve for them. If your G of X is quadratic, then your trial solution should take the form A2x squared plus A1x plus A0. But remember, even if it's just one term in x squared, you should take all this form as your YP and find A1, A2, and A0. P3x cubed, P2x squared, P1x plus P0. This is cubic. Then also, your YP should be cubic, A3x power 3, A2x squared, A1x, A0. And you have to write all this structure and find A0, A1, A2, and A3. If it's now a polynomial of degree n, Pn minus 1 x power n minus 1, P1x plus P0, then you should take An x power n plus An minus 1 xn minus 1 plus An minus 2 xn minus 2 plus An just A1x and then plus A0. Then solve for A0, A1 up to An. If you have a constant, say k, times e raised to power rx, then your particular solution should take the form constant times e raised to power rx. If your solution is, if your G of X is of this form, or a constant times sine, then your solution should take the form A1 sine omega x plus A2 cos omega x. So this, whether there's only one sine or one cosine, it should be a linear combination of sine and cosine. If we have a polynomial of degree n, multiply a polynomial of degree n, then this is what you are saying is An x power n plus An minus 1 x power n minus 1 plus A1x plus A0, and then solve for A0, A1 up to An. If we have a polynomial of degree n multiplied by e raised to power rx, Then what you do, you'll have an xn plus an minus 1 xn minus 1 plus a1x plus a naught multiplied by e raised power r x. If you have Pn of x, a polynomial of degree n, multiplied by e raised power rx cos omega x, or we have a polynomial multiplied by exponential times sine, then you should have this form. Multiplied by e raised power rx cosine of omega x plus bn x power n bn minus 1 x power n minus 1 b1x plus b naught e raised power rx sine of omega x. So those are the trial solutions for particular solution with different structures of g of x. Next session, we'll do example to illustrate how the method of undetermined coefficients work. Thank you.